Hi everyone. I hope you're having a good Monday and or a good week, I should say, because I'm not sure exactly which day you're going to log into this. I hope you started on Monday. Anyway, hope you're all doing well. I wanted to talk to you about our next lesson or next assignment. We're going to be working with exponential functions. So exponents, you might recall, mean repeated multiplication, and I'm going to show you an example of an exponential function. It's an equation that would look something like this. Maybe y equals 2 to the power of x. So we can work with this by plugging in a bunch of different x values. So for example, and I get to choose whatever x values I want to put in there. I don't have a prescribed way of coming up with them. I just get to choose whatever I want. And I like to keep my x values small because then that makes the math, easier. So I'm going to start with the number 1. And so this is the way that would work. If I plug in 1 for x, that would mean that y equals 2 to the power of 1, which means that y equals the number 2. If I plug in 2, that would mean that y would equal 2 to the power of 2, which that's 2 times 2, which is 4. That would mean that y equals 4. And if I plug in 3, y would equal 2 to the power of 3, which is 2 times 2 times 2, so that equals 8. And if I plug in 4, that would mean that y equals 2 to the power of 4, so that would be 2 times 2 times 2 times 2, which would then equal 16. So like we said, exponents are repeated multiplication, and you get to choose whichever x values you want to plug into the equation, and then you work out the math to figure out the value of y. Now these numbers that I just came up with are actually coordinates that can be graphed. So for example, this first one would be the point 1, 2, because x is 1 and y is 2. Second one would be 2, 4, because x is 2 and y is 4. Next one would be 3, 8. And the next one would be 4, 16. Now something I'd like you to notice is in this pattern is as the exponent increases, as you move from 1 to 4, as you move from 1 to 4, what's happening is obviously you're multiplying by 2 one more time. So as you move in this direction, you're multiplying by 2. And so that's important to know because we can also use exponents of 0, and we will have to use the exponents 0 and a couple of negatives. So I will choose -1 and -2 to put in here. Now, if we are multiplying by 2 as we move down the table, then as we're moving up the table, that means that we're actually dividing by 2. So what I mean here is that if I go from 16 to here to 18, right, that means that in this direction, if I'm going from 16 to 18, I'm actually dividing by 2. And if I go from 8, I did say 16 to 18, but I meant 16 to 8. If I go from 8 to 4, I'm actually dividing by 2. And if I go from 4 to 2, I'm dividing by 2, which means that if I go from 2 to the next one, I'm going to have to divide by 2. Now 2 divided by 2, that's where we are. 2 divided by 2 is going to equal the number 1. And then I'll go one more time, and I'm going to divide 1 again by 2. Well, 1 divided by 2 is 1/2. And I'm going to go one more time. I'm going to take 1/2 and divide it by 2. And that will give me 1/4. It's important to know that, because these are also points that we would graph. So 0, 1 will get graphed. -1, 1/2, and -2, 1/4. And you'll notice that what's happening there, this is supposed to be a comma right here. What you'll notice is that as we keep going backwards and dividing by 2, we keep getting closer and closer to 0. And so what's happening is we continue to divide by 2 and continue to divide by 2, and the numbers get smaller and smaller and smaller, but they don't actually touch 0 or get to 0, because it's not possible to divide anything by 2 other than 0, that is. It's not possible to divide a number by 2 and get to 0. You're just going to get smaller and smaller and smaller numbers. What I'm saying there, it's kind of like taking a piece of I don't know, fabric, cutting it in half, cutting it in half again, cutting it in half again, and continuing to cut it in half. Even though they are going to get smaller and smaller and smaller, the pieces will never disappear into 0. So let's look at another one of these. I'm going to work with y equals 5 to the x. Now, something I want to be clear on is each one of these parts of the equation has its own name. 5 is the base that we are working with. X is going to be the exponent. That's the power. And y is the value of the function. Whoops, that's supposed to be a v. That's the value of the function as it changes. Goodness gracious. There we go. Sorry, my handwriting right now is really challenging. Anyway, so that's what each part and piece there is. So let's do a table of values, an XY table for this one. I'm going to leave some space here for my negatives. So I'm going to have -2, -1, 0, and then I'm also going to include 1, 2, and even 3 for this one for my exponents. I'm going to start where x is 1. If x is 1, then y will equal 5 to the power of 1, which is 5. And then it's kind of easy to go from there. If x is 2, y would equal 5 squared, which is 5 times 5, so that gives me 25. If x is 3, y will equal 5 to the third, which again is 5 times 5 times 5, which is 125. And I really don't have to do all of this multiplying here, because as you know, all we're doing is we're just multiplying by 5 one more time as we move down the table of values there. So moving backwards, if I divide by 5 to get to the one just before, the exponent just before, 5 divided by 5, if I'm moving in this direction, I'm going to divide by 5, so that'll give me 1. And if I divide by 5 again, that'll give me 1/5. And if I divide by 5 again, that'll give me 1/25. So you'll notice that there is something that is exactly the same, or hopefully you'll notice as you continue, this is exactly the same as the previous function when the base was 2. When we have a power of 0, we will always, 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 always get a value of 1. Anything raised to the 0 power will give us a value of 1. So that's always going to be one of our points that we will graph. So the points that we have here are -2, 1/25, -1, 1/5, 0, 1, 1, goodness gracious, that's supposed to be 1, 5, and 2, 25, and 3, 125.